Hello students, welcome to MacTab. I am Ayush and here I am again with you with the next lecture of the series of number system. I hope you have completed all the previous lectures. If not, I advise you to complete those lectures. Although you can start from this lecture also, as in this lecture we'll start our new topic, that is playing with numbers. In this class, we'll talk about the factors of the numbers. So let's come to the topic. Here it is written that Nick has six triangles with him. Okay, he wants to arrange them in rows in such a way that each row has same number of triangles. How many ways are possible to arrange the triangles? Okay, I want you guys to try. Just try to make different situations in which we can place six triangles in rows so that each row is having the same number of triangle. Let's say I take case 1. This is case 1. Let's say I put all the triangles in one row like this. I have placed all the six triangles in one row only. What else I can do is this. One, two, three. Three triangle in a row and three in other row. So we have same number of triangles in both the rows. I want you guys to, this is case number 2. I want you guys to tell me how many other ways are possible. Just try. I hope you have think about some situations, right? So now let's come to another one. This you might have figured out. What else I can do is this. Two triangles in a row, two triangles in second row, and two triangles in third row, right? So still I am having same number of triangles in all the three rows. Here we have two, then two, and the total is, here we have total six triangles, again we have total six triangles, and again we have total six triangles. Now in first case I put all the triangles in one row, then three in each row, and we took two rows, right? Then we took three rows and two in each two triangle in each row. Now, is there any way possible that we can distribute these? Is there any way possible in which we can distribute these six triangles in four rows? Is there any way possible? Just try it yourself. Just try to put these triangles in four rows so that each row has same number of triangles. Let's try. One, two, three, four, five, six. That means we have used all the six triangles, but the last two rows. This is row three, row four, right? This is one and two. That means third and fourth row have only one triangle, and one and two rows are having two triangles each. That means the number of triangles are not same. That means it is not possible to do it this way. We cannot distribute equal number of triangles in four rows. Okay, try it for five. One, two, three. That means first row, second row, third row, fourth row, fifth row. Like this. Fourth row and fifth row. And then this one triangle, two triangle, third triangle, fourth triangle, fifth triangle, and the sixth triangle. We have used all the six triangles, but we are not using same number of triangles in each row. That means it is not possible for five rows also. Let's try for six rows. Let's say one, first row, second row, third row, fourth row, fifth row, and then sixth row. One triangle here, one here, one here, one here, one here, and one here. So I have used all the six triangles, and I have six rows now, and each row is having same number of triangle, that is 1. So I can say that this is possible, right? So these are the only cases possible. That means 4 and 5 are not possible. Why? Because here I have one row. Let me write it here with different pen so that it will be easy for you guys. So we have here I am writing rows, and here number of triangles. Number of triangles. Okay. So in first case I took one row and six triangles, right? In this case, case 1. Case 1. In second case, I took two rows and three triangles each, right? In the third case, I used three rows, two triangles each. In fourth case, uh, we do not have similar number of triangles, so this is not possible. Same is for five rows, because here also we do not have same number of triangles in each row. Then we took this is six rows and one triangle, right? So notice this thing, that we have reached same. Here I have 1 into 6. Here I have reached again to 6 into 1. 6 into 1 is nothing but 1 into 6. I can write it any way I want, right? In any order. That means 6 into 1 is 6, and 1 into 6 is also 6, right? So why it is so? Why 4 and 5 is not possible? Because this 1, 2, 3, and 6 are the factors of number 6. What does it mean? Factors of number 6. 1, 2, 3, and 6. These are factors of number 6. Factors. Factors of number 6. That means if a number is factor of a, if these numbers are factors of 6, that means 6 is divisible by each one of these numbers. That means if I divide 6 by 1, I'll write 6 here, and I'll write a 6 here, and there is no remainder left, right? Similarly, I can divide it by 2. 2 into 3 is 6, no remainder left. Then come to this 3. 3 divided by 6. 3 into 2 is 6. That is no remainder left. And this 6. 6 divided by 6. 6 into 1 is 6. Again no remainder left. So if there is no remainder left, that means the number is a factor of this 6. But let's take 4. Remember, if we took the case of four rows, then we were not able to put similar number of triangles in each row. Remember? Yeah, this is why it is so. Because if I divide 6 with 4, what will I get? 4 into 1, 4. I left with 2. That means 2 is remainder here. Remainder. Okay, it is remaining. It is remaining part. This is divisor. This is divisor by which I am dividing the number. This 6 is dividend. Dividend. And this 1 is quotient. I'll write it on a different page for you guys. Don't worry. So you can see if any number is, if we dividing 6 with 4, we are getting a remainder. So any number which is giving us a remainder, that means that number is not a factor of 6. Got it? So now let's say if I want you guys to tell me what are the factors of 8, how will you do it? Just check from 1. Is 1 a factor of 8? 1 into 8 is 8. That is no remainder left. So 1 is the factor of 8. Now come to 2. 2 divide by 8. 2 into 4. 2 into 4 is 8. No remainder left again. So 2 is also a factor. Now try with 3. 3 divide by 8. 3 into 2 is 6. And 2 is left. So here we have a remainder 2. So will this 3 be a factor of 8? No, this is not a factor of 8 because here we are getting a remainder. Now come to 4. After 3, 4. 4 into 2 is 8. No remainder. That means 4 is a factor. Come to 5. 5 into 1, 5. 3 remainder. That means not a factor because we are getting a remainder. Now come to 6. 6 into 1, 6. Again remainder. That means 6 is not a factor. Then come to 7. 7 into 1, 7. Remainder 1. That means still we are getting a remainder. That means this 7 is not a factor of 8. Now come to 8 itself. 8 and 1. 8 into 1 is 8. That means no remainder left. So 8 is also a factor of 8. So we can say that we will check only till we reach the number itself. We are checking for 8 and we reached 8 here. That means the dividend and the divisor became same. So we'll check till this only when we get the same number. So we can say that factors, wait a second. Yeah, factors of 8 are 1, 2, 4 and 8. That means 8 is divisible by all of these numbers. If I want to divide 8 by 4, I can directly write 4 into 2 is 8. That means this 8 is completely divisible by 4. That means now I want you guys to write this. Factor of a number will will exactly divide the number without leaving any remainder. Got it? That means factor of a number will exactly divide the number without leaving any remainder. If I am dividing this 8 and with 4, 4 is a factor of 8, so 4 will completely divide it and there will be no remainder left. So this is what this definition says. Factor of a number will exactly divide the number without leaving any remainder. Got it? Now come to this. 1 is a factor of every number. That means if 1 is a factor of every number, then 1 can divide any number. Right? So we have to check this if it is true. If 1 is a factor, that means it will divide every number if it is a factor of every number, because a factor divide the number exactly without leaving any remainder. So let's check for 2. So if I divide 2 with 1, I'll simply write 1 into 2, 2 and no remainder left. That means 1 is a factor of 2 because it is exactly dividing the 2 without leaving any remainder. Now let's check for 3. 3. 1 into 3 is 3. Again no remainder left. Okay. That means 1 is a factor of 3 also, because 1 is exactly dividing 3 and there is no remainder left, right? Now let's check for 10. 1 into 10 is 10 and still no remainder. That means I can say that if I multiply 1 with any number, let's say 576, it will become 576. So it will completely divide this number, right? That means there will be no remainder left. So we can say that 1 is a factor of every number. Factor of every number. Every number, because 1 can divide any number without leaving any remainder. Let's say if I take 18 here, I'll just simply say 1 into 18 is 18 itself and there is no remainder left. So this 1 is a factor of every number. Got it? Why it is so? Because when I multiply any number with 1, I'll get the same number. So if I am getting 18, I have to divide 18 and I am getting the same number 18. How will be there any remainder? Got it? That means 1 can divide any number, because division is nothing but take a part out of it. If I have one, uh, let's say one cake, this is a cake and I have to divide it with 1. That means only one person want to eat this, so he can take the whole cake, right? This is the concept. If I want to divide 18 in two numbers, how will I do? Not 18, let's take a smaller number first so that it would be easy for you guys to understand. If I want to divide 2, I'll add divide it like this: 1 into 1, 1 for each. Right? If I want to divide 4, I'll divide it like this. If I want same, uh, if I want to divide it in equal number of parts, I'll divide this 4 like this: 2 and 2. That means if there are two persons and I want to divide 4 equally to them, I'll give 2 to one and this 2 to other. And if I add these two, 4, 2 plus 2 is 4. But if I have 4 and I want to divide it to one person, I can easily divide it. I'll give the whole part to this person 4. This I'll give this whole part 4 to this person. Got it? So we can divide anything with 1. So we can say that 1 is a factor of every number, because 1 can divide any number no matter how big the number is. Let's come to the next one. Every number is a factor of itself. That means if I write 5 and I say 5 is a factor of 5, will it be? Let's check. 5 divided by 5. 5 into 1, 5. No remainder left. That means this 5 is exactly divisible by 5 and there is no remainder left. Again, if I check for 8, 8 divided by 8 only. So 8 into 1, 8. No remainder left again. So we can say that just like 1, every number is a factor of itself, as it is written here. That means if I write 12 and I want you guys to tell me two factors of this number 12. So the two factors will be 1 and 12 itself, because 12 is divisible by 1 as well as 12. Let's check. 1, 12. 1 into 12 is 12. If I am dividing this 12 with 1. So 1 into 12 is 12 and no remainder left. That means 1 can exactly divide this 12 and we are having no remainder left, right? Now let's check for 12. 12 into 1 is 12. Still no remainder left. That means we can say that uh, 1 and the number itself will always be the factors of any number. Got it? That means if I check for 17, so if someone asks you, tell me two factors of 17, what will you say? One is 1 and the other will be 17. There can be other factors as well, but every number will have 1 and the number itself. That means here I am checking for 17 and here I am writing 17. That means 1 and the number itself will always be the factor of any number. Got it? If I check for 55, that means 1 and 55 will always be the factor of 55. Got it? I hope now I made my point clear. Now let's come to the next one. Every factor of a number is an exact divisor of that number. This is what I am teaching you for the last 2 minutes. That means if let's say 5, what are the factors of 5? 5, 1 and 5. That means this 5 and this 1 will exactly divide this 5. That means there will be no remainder left. 1 into 5 is 5. Let's check for 16. What are the factors of 16? 1 will be the one factor, right? Other will be 16. Now let's check for 2. 2 divided by 16. 2 into 8. 2 into 8 is 16 itself. That means no remainder left. That means 2 is also a factor of 16. Let's check for 3. 16. 3 into 5 is 15. And we are left with 1. That means 3 is not a factor. So all the factors are dividing the number exactly. That means leaving no remainder. If any number is leaving any remainder, just like in this case of 3, which is dividing 16, that we are in this case 1 is the remainder. So we can say that this 3 is not exactly dividing 16. So it will not be the factor of 16. So we can say that every factor of a number is an exact divisor of that number. That means if if someone says 2, 2 is a factor of let's say 16 or let's say 14. So how will you check? You'll just check like this. You'll just divide 14 with 2 and check if there is any remainder left. 2 into 7 is 14. That means no remainder left. So 2 is a factor of 14. So every factor of a number is an exact divisor of that number. Now I want you guys to tell me this. Yeah. Here it is written 22. I want you guys to check if 3 is a factor or not. Factor or not. Just check for 22. Is 3 a factor of 22 or not? Pause the video and just try it for yourself. How will you proceed? I hope you have done this. Now, how we will check? We will just try to divide this 22 with 3. So this is 22. I am dividing it by 3. So 3 into 7 is 21. And we are left with remainder 1. That means we are having a remainder. So this 3 is not a factor of 22. This 3 is not a factor of 22 because we are having remainder 1. I hope I made this clear to you. Now let's come to this. Every factor is less than or equal to the given number. What does it mean? That means if I am talking about 6, then all the factors of 6 will either be smaller than factors. All the factors will either be smaller than 6 or equal to 6. Why? Because if I check for 7, let's say, not 7, if I check for 8, let's say, So I'll check from 1. So 1 is 1 will definitely be a factor because I have told you that 1 and the number itself will always be the factor. So I'll write 1 here. Then I'll check for 2. 2 into 4 is 8. That means if I divide this 8 with 2, it will exactly divide, right? So 2 is also a factor. Now let's check for 3. 3 into 2 is 6. It is leaving a remainder 2. So it is not a factor. Now let's check for 4. 4 into 2 is 8. No remainder left. That means 4 is also a factor. Now 5 into 1, 5. We are left with 3. So it is not a factor. What about 6? 6 into 1, 6. 2 remainder. That means it is also not a factor. Then 7. 7 into 1, 7. The remainder is 1. So it is also not a factor. Now let's check for 8. 8 will definitely be a factor because 1 and the number itself will always be the factor of a number. Now we will not check for more than 8 because we have reached the number itself. So if we are not checking more than 8, how can a factor be more than this 8? So we can say that factors of a number can either be smaller than this 8 or can be equal to this 8. That means this 1, 2 and 4 are smaller than 8 and this 8 is equals to 8. We will not check for 9 because if I want to check for 9, I will not get any term that can divide this because if I write 9, 9 into 1, 9, it is bigger than this 8. So we cannot divide this. I cannot say that this divide 2 with 3. I cannot divide it exactly because this 3 is bigger than this 2. Got it? So we will get the answer in fraction or we cannot divide this. Got it? And right now we are talking about whole numbers, so we will not consider fractions. Got it? So every factor is less than or equal to the given number. We have proved it. If you guys want, you can check for, let's say, 6. Tell me, is 1 the factor of 6? Yes, because 1 is the factor of every number. Now let's check for 2. If I divide 2, if I divide 6 with 2, what will I get? I'll get 6. 2 into 3 is 6. That means this 6 is exactly divisible by 2. So no remainder will be left. So this 2 is also a factor of 6. Now check for 3. 3 into 2 is 6. So 3 is also a factor because if I'm getting 6 by multiplying 3 with any number, that means it is a factor because see, this is what I am doing. 3 into 2. Here I am doing 3 into 2. Here also I am doing 3 into 2, 6. No remainder left. So 3 is also a factor. Now let's check for 4. 4 into 1, 4. Remainder 2. 4 is not a factor. Similarly, 5. 5 will also uh, 5 will also leave a remainder 1. So we reach to 6. That means 6 will definitely be a factor of the 6 because 1 and the number itself will always be the factor of the number. So we have reached till 6. Now we will not check for more than 6 in case of factors because a factor can never be larger than the number itself. Got it? So here we have numbers we have factor which are smaller than this 6 and a factor which is equal to this 6. That means we have proved this, that every factor is less than or equal to the given number. I hope I made this clear to you. So that's all from my side for today. I hope you got the concept. If not, I advise you to rewatch the video and you'll definitely got the concept. In the next lecture, we'll talk about multiples of the number. In this class, we have learned about the factors. In the next class, we'll learn about the multiple of the numbers. Till then, bye bye, take care, and study hard.